Now we're going to talk about statistical tools for QI. The objectives for this lesson are to conduct statistical evaluation of QI projects, interpret the findings of data from a QI project, and produce figures of QI findings for dissemination. Tables and words should be used to describe the participants' patient age, race, gender, diagnosis, or clinician discipline year or years of experience, or other characteristics or demographics. And then also for survey results, before and after education scores, or p-value comparisons when possible between the before and after scores on each question asked. Here's an example of what a characteristic table would look like for age, race, and gender, or a pre-post education test if they understood the procedure, washed their hands, used the cleanser, and the sum score. Also, there's evaluation with 8 major statistical tools for QI: a cause and effect diagram, driver diagram, failure modes, flow charts, histograms, Pareto charts, control charts, and scatter diagrams. We'll discuss each in detail. Here's what a Fishbone cause and effect diagram looks like. It's a structured brainstorming tool using categories to explore root causes for an undesirable effect. A cause and effect diagram is a challenge for QI teams to determine what changes can be tested to improve a process. The diagram helps teams explore and display causes contributing to an effect or outcome. It graphically displays the relationships of causes that affect each other and helps identify areas for improvement. Here are the instructions. You write the effect wished to influence on the right. You draw horizontal lines across the page, left from the box, and you decide on 5 or 6 categories of cause for the effect. Standard categories are materials, methods, equipment, environment, and people. And you draw diagonal lines above and below to create the fishbone and label each to put in a box. For each category, generate a list and subcategories as needed. Develop the causes by asking the simple question, why? So here's what a conceptual view of a driver diagram looks like. You can see what the aim or outcome is that you desire, and what the primary drivers and secondary drivers are, the specific change ideas, and the change concepts. So as you can see, the primary and secondary drivers are the key leverage points in the system, and the specific change ideas or change concepts are the specific ideas and concepts and bundles that could generate the desired state. So a driver diagram is a visual display of teams' theory of what contributes to a project aim. A picture to stakeholders is a shared view. It shows relationships between the aim of a QI project and the primary drivers to achieve the aim, and secondary components and change ideas to actually test within a QI project. So on the left, you list the project aim. What's to be improved on, by how much, by whom, and by when, and you put a box around it. To the right of the aim is the primary drivers. These are the most significant high-level influencers on the aim. You draw a box around each driver with a line to connect to the aim. And to the right of that, you list as many secondary drivers as you can think of. Again, draw a box around each with lines to the primary drivers that they associate with. Show strong relationships with solid lines and weaker ones with dotted lines. To the right of each secondary driver, list ideas to test that will influence the secondary driver. Change ideas can connect to more than one secondary driver. So here's what a failure modes and effect analysis looks like. These are usually called FMEA. It's a 3-path model. As you can see, path 1, 2, and 3. 1 is what are the functions, features, or requirements. If there's no function, partial or over, intermittent or unintended, and what are the effects and how bad is it? Path 2 is, what are the causes? Can it be prevented? And then path 3 is, how can the cause be detected? And how good is this method at detecting it? And then what are the actions? Design changes, process changes, error proofing, special controls, or mistake proofing, and changes to standards, procedures, or guides. In FEMA, it's a systematic, proactive analysis of a process in which harm can occur. Teams representing an entire process convene to predict and record where, how, and what extent a system might fail. Experts work to devise improvements to prevent failures. They evaluate steps in the process, what could go wrong, when it would fail, and what the consequences would be. It's useful to evaluate a new process prior to implementation or assess proposed changes in a process. Here's the instructions. You select a process to evaluate, convene a team, have the team list all the steps in the process, focus on high-risk failures, plan the actions to reduce harm, and you conduct the quality improvement. And here is a flow chart. These are commonly used to lay out in pictorial manner how things occur and in what order they occur in. So a flow chart is a process map. It's a visual representation of the sequence of steps in a process. A team brainstorms all the steps. Diamonds are points where decisions need to be made, and you write yes or no questions. And you use lines between the boxes. And diamonds. It identifies problems, bottlenecks, and focuses the discussion, and identifies resources. Here are the instruction. It gets you need to get people who know the process. Start by defining first and last step to share understanding of where the process begins and ends. Use shapes to fill in all the steps and move around as needed. Some steps may be parallel. Review the flowchart for accuracy and completeness, and assign action items to the team to fill in unfamiliar steps and verify accuracy, and then analyze and actually use the flowchart. So here's a histogram. Histograms are summary statistics shown in a bar chart to show variation and analyze patterns. So the instructions are to collect continuous data and tally in a data set. Choose a cell width to show the range, add the labels, a title, and analyze the results of the pattern. And here's a Pareto chart. See how it's a little bit different than a histogram? Pareto charts are a type of bar chart arranged in order of the large to smallest data. It displays vital factors to focus the work. The instructions are to draw a label on the vertical horizontal axis, add percentages from 0 to 100, and then explain the diagram. A Pareto chart creates a bar chart of the causes of the problem in order from most to least frequent, so that you can focus your attention on the most frequent elements or combination of elements. And here's a run or control chart. Run chart graphs are of data over time to determine if change led to improvement. Control chart upper-lower limits help teams distinguish variation in the process to see early effects of improvement. You collect data in time sequence and you draw a vertical and horizontal axis and label. You plot the data points and lines to connect, and you calculate the median or mean on the run chart. Control charts calculate mean and add limits, and then you add a title and the notes. And here's what a scatter diagram looks like. These aren't used too often. It's a graphic plot of two variables to identify the cause and effect relationship, one variable on each axis. The instructions are to collect the data, label the axis, plot it, and then add the titles, and then study the pattern. Most graphs can be produced in Word or in SPSS or SAS statistical software. They are always used to summarize the results or findings of data collected during quality improvement. You also need to look at the implications of effect size. It's a measure of how important an improvement is. It's used to determine the improvement after quality improvement projects are completed. A general rule of thumb is a small improvement is 10%, whereas medium is 15% and large is 20%. So it's basically a comparison of two t-test independent samples. If the means don't differ by greater than 0.2 standard deviations, the difference is trivial, even if it's statistically significant. This is commonly used in analyzing it within quality improvement projects. We do this because we want to know how much of an effect a change has on the outcome. Thank you very much.